In today's class, we are going to learn principle of dominance of pure strategy game in operations research. Already we have covered how to find value of the game, how to find the probability of pure strategy and mixed strategy game. So this is about principle of dominance. First, let's discuss what is principle of dominance. This states that if the strategy of a player dominates over another strategy in all conditions, that is, strategies of a player dominates another strategy in all conditions, then the later strategy can be ignored because it will not affect the solution in any way. That is, the row which is not affecting the solution. So that row we are removing, okay, ignoring. So this will be clear when I will go through the example. If all the elements in a row of a payoff matrix are less than or equal to the corresponding elements of another row. That is, corresponding means this is related to this. Okay. And this one and this one. This is the correspondence. This one and this one. That is, you are comparing these two elements and these two elements. Okay. That is what? If all the elements in a row of a payoff matrix are less than or equal to the corresponding elements, if they are less than, then the later dominates and the former is ignored. Here, every element in the second row is less than or equal to corresponding elements of the first row. That is, the second and the first row we are comparing. And every element of the second row is less than or equal to every element, corresponding element of the first row. Hence, the first row dominates and the second row can be ignored. One is dominating and the other one is being ignored. Okay. If all the elements in a column of a payoff matrix are greater than, that is what we are taking for column, we are going for this greater than or equal to, and for row we were going for less than or equal to. Okay, so greater than or equal to the corresponding elements of another column, then the later dominates and so the former is ignored. Columns are being compared and it is checking, that is, the elements, corresponding elements of one to the other. Which one you are taking, that will be more clear. Okay. So the relation here is greater than or equal to. And when we are taking for row, the relation is less than or equal to. We are checking for that. If it is less than or equal to, if it is greater than or equal to. Okay. So consider this example. Here every element of the second column greater than or equal to corresponding elements of the first column. Right. That is, 3 is greater than 1. 1 is greater than -2. Hence, the first column dominates and so the second column can be ignored. This is dominating and this is to be ignored. Okay. So, if the combination or average of two or more columns or rows dominates a column or a row, then the later is ignored. This is another way. That is, while doing, in some cases you have to take average of two or more columns or two or more rows and you have to continue the solution. Okay. So, if that is the case, such row or such column dominates a column or a row, then the later is ignored. Then this particular will be ignored. Okay. So, these are the three ways for principles of dominance. Three methods, not methods. So, suppose for every problem you have to go for row reduction, then column reduction. In some cases you have to go for this combination. Okay. Now let's see the example of pure strategy game for principle of dominance. Question is here. The following table represents a payoff matrix with respect to the player A. Solve it optimally using dominance property. So this is a question. Solve it optimally using dominance property. optimal solution. Okay, that is what, solve it optimally. And we have to use the dominance property. So this is a question for you. Player A is there and the strategies are A1, A2, A3 and E4. And for player B, it is B1, B2, B3, B4 and B5. And these are the values. Okay, this is a question for you. Now coming to the solution, first you have to check whether this is having saddle point or not. That is, I am showing here whether this is a pure strategy game or not. We know how to do that. Okay. So for that, first you have to find the row minimum. We know that is row minimum you have to find. And the minimum of the first row is 4. Minimum of the second row is 5. Of the third row is 8. And of the fourth row is 4. Okay. So these are the values, minimum values. And then from this you are taking the maximum value, right? From this you have to take the maximum, this is 4, okay? And from here you have to take the maximum value and that is 8. Okay, maximum. And then coming to the column, we are taking the maximum value of each column. This is 8. And here it is 9. This is 11. This is 10. And this is also 10. For row, we took the maximum value. For column, you have to take the minimum value, and that is 8. So what's the next step? You have to compare maximum value with the minimax value. Maximum value is 8 and minimax value is also 8. Okay, that is 8 is equal to 8. Right? So maximum value is equal to minimax value and that is equal to 8. Therefore, this is a pure strategy game and we can write the value of the game is 8. And the probabilities are of player A. This is the value. Okay, this 8. We know how to take the saddle point. So here this was the row with the minimax value and no, not row, this was a column with the minimax value and this was a row with maximum value. Okay, and the combinations is 8. This is the value. So you can write the value of the game is 8 and the probability, this is the location, right? So 0 for A, it is 0, 0, 1 and 0. For B it is 1, 0, 0, 0 and 0. Okay, so this is the probability. And here we are having the value of the game as 8. Now we are going for the solution using principle of dominance. For that, the first step is take the total of each row. Okay, this is a pair of matrix with you. Now we know using normal method we got the value of the game as 8. Right. Now we are checking the solution or finding the solution using principle of dominance method. So for that the first step is take total of each row. For the first row, that is 4 plus 6 plus 5 plus 10 plus 6 and that is 31. And for the next row it is 39 and for the third row it is 47 and for the fourth row it is 30. So this is the sum of the values of each rows. Now the second step is take the least total. So here the least total is 30. Okay. Now the step 3, compare row 1 values with the least total row. That way we have to continue. Okay. So here the fourth row is having the least value and we are going to compare this least total value row with the other rows. Okay, and we know for row reduction you are checking for less than or equal to condition. So here this is x and these are the y values. So each value of x is compared with the corresponding y values and checking whether it is less than or equal to y. At that time only dominance and row ignorance is happening. Okay, so here fourth row and first row is compared. It is checking for less than or equal to. So take the first value of fourth row 6 and 4 of the first row. Okay, 6 of the fourth row and 4 of the first row. They are compared. So the condition is wrong. That is 6 is not less than y. It is not less than y. So no dominance. Okay. Now you have to compare 4 and 2. Again 6 is less than 7, that is okay. 4 is less than 8, that is okay. But here 10 is greater than 5. So you cannot continue and hence no dominance. Now compare the third row and the fourth row. These two rows. Okay. Now compare 6 is less than 8, that is okay. 4 is less than 9, that is okay. 10 is less than 11, okay. 6 is less than 10, okay. 4 is less than 9, okay. So all the values are now lesser than the corresponding values of the third row. So you can ignore the fourth row. Okay. Now you are having only these three rows. Now take the next highest value, that is 30 we have taken. Now take 31. Next least value. Okay, next not highest, next least value. So 31, 39 and 47 we were having and the least value is 31. So now this is x. The first row is x and compare with the other two rows. So first and second, compare it. 4 is less than 7, it is okay. 6 is less than 8, okay. 5 is equal to, okay. But here see, 10 is greater than 9, so no dominance. Okay. Now compare the first row and the third row. Okay. So 4 and 8, it is okay. 6 and 9, 6 is less, okay. 5 is less, that is okay. Also okay. 10 is equal to, okay. And 6 is less, okay. Now see, this row you have to ignore, okay. Now you are having second row and the third row with you. Now again compare. So now the totals are 39 and 47. Now the least total is 39, right? So start comparing. 7 is less than 8, it is okay. 8 is less than 9, okay. 5 is less than 11, that is also okay. 9 is less than 10, okay. But 10 is greater than 9, so no dominance. Okay. Now take the next value, next least value, and that is 47. Okay. Now this third row is compared with the second row. Now 47, that is the third row is x and the second row is y. Okay, now compare. 8 and 7 we are comparing. So 8 is greater than 7, right? So no dominance. Now you are having at the end, after row reduction, you are having the two rows, second row and the third row. Okay. After row reduction, now you are having this pair of matrix with you. Now you have to go for the column reduction. For column reduction, first step is find total for each column. So for the first column, 7 plus 8, it is 15. 8 plus 9, it is 17. This is 15. Okay. 15, 17. 5 plus 11 it is 16. 9 plus 10, 19. And 10 plus 9 also 19. So first step over. Now select the highest value. So here two highest values are there. So take any one from that. I am taking the fourth column. Now compare highest total column with the other columns. Okay. Now here fourth column is compared with the other one, that is 1, 2, 3 and 5. So let us compare fourth row and first row. Sorry, fourth column and first column. Okay. So here we have to go for the condition greater than or equal to. For column reduction, we have to go for greater than or equal to, right? So check whether x is greater than or equal to y. So this is x and now this is y, right? So compare 9 is greater than 7, that is correct. 10 is greater than 8, that is also correct. Okay. Now you have to ignore fourth column. Now the next highest is 19, this 19. Okay, now this is x. Compare, again compare. So fifth column and first column I am comparing. 10 is greater than 7, that is correct. 9 is greater than 8, that is also correct. Now ignore this column. Okay, now you are having column 1, 2 and 3 with you. Now again, next highest is 17. Okay, compare second row and first row. 8 is greater than 7, that is okay, and 9 is greater than 8, that is also okay. Now ignore this column. Now you are having the balance first column and third column with you. Now again compare. Next highest total is 16. So this is x and this is first column is y. Okay, start comparing. 5 is less than 7, right? 5 of the third and 7 of the first column. 5 is less than 7. So this condition is wrong. So no dominance. Now the next highest, that is 15, right? The first column. Now this is x and compare it with the third column. Now the third column is y. Okay. Now compare it 7 and 5. 7 and 5. 7 is less than 5, right? So again the condition is wrong. So you are having, that is no more dominance. Okay. Now you are having the values as 7, 5, 8 and 11 with you. Okay. So this is column reduction. Now we have done row reduction and column reduction and you are having this pair of matrix with you. Now again continue with the row reduction. So row reduction, you know, as usual, find the sum of the row 5 plus 7, that is 12, and 8 plus 11 is 19. Take the least total, this is x, right, and compare. So 7 is less than 8. So less than, you have to go for row reduction. So 7 is less than 8, it is correct. 5 is less than 11, that is also correct. Now ignore the second row. Now you are having only 8 and 11 with you. Okay. Now after row reduction, column reduction and again row reduction, now you are having this pair of matrix with you. Now go for column reduction. So here the sum is 8 and here it is 11. Now compare. This is the highest value, right? So this is row, column 3 is compared with column 1. It should be greater than or equal to. Here 11 is greater than 8. So you can ignore the third column. Now you are having only this value. Okay. And this value is the third strategy of player A and the first strategy of player B, that is A3 and B1. Okay, so this is the value of the game, which is same as we got in the normal method. And the combination is for A3 and B1 we got 8. Now we have to write the probability, and as we know the value of the game is 8. Okay. Now we have to conclude. This is the payoff matrix which we got as a question. And for player A, for strategy 3 we were having 8, and for player B for strategy 1 we were having 8, right? So this was a combination which we got. Now you have to write value of the game is 8, and the probabilities as usual we know for A 0 0 3, right? For the third strategy you are having the value, so that is 1 and the others are 0. And for player B, for the first strategy you are having the combination, you are getting the value as 8, so that is 1 and the others are 0. Okay, so this is principle of dominance method to find value of the game. That is, first you have to go for the row reduction. Find the sum of the row, each row, pick the minimum value, minimum total, and compare it with the other row. Go for x less than or equal to y. Okay, and check whether dominance is there or not. If no dominance, check with the next row and so on. And after that, go for the column reduction. Then a column reduction means you are checking greater than or equal to. Okay. And again row reduction, column reduction, and at last you have to get the value of the game. This is for pure strategy method game. Okay, and next class we are going for mixed strategy game, how to solve using principle of dominance. Hope for pure strategy game, principle of dominance is clear for you. Thank you.